See about OLAP operations in multi-dimensional data model. So there are different types of OLAP operations which can be done in the operational data warehouse. So we can see some of these OLAP operations. Okay, these OLAP operations enables us to query the data warehouse so that in order to do analysis on the data. So it provides a flexible exploration of data trends from various perspectives. Next, we can see about the concept hierarchy in OLAP. So there are various levels of abstraction. So it facilitates roll-ups and drill-down operations, and data summarization helps in aggregate data at higher levels. So by using this data summarization, we can aggregate data at higher levels. So the detailed data will be aggregated in order to form the sum of the higher level detail. So by using this, we can shift perspective dynamically, not to explore trends or patterns. So we can see the benefits of OLT in our data analysis next. So the various benefits are flexibility, interactivity, granularity, and perspective. Yes. So flexibility means dynamic navigation through data hierarchies. You can dynamically navigate to the various hierarchies data. Then interactivity. Interactivity means real-time querying or immediate insights. We can able to query the data warehouse or immediate insights. So there is interactivity and granularity. It supports both higher level summaries. It supports summarization of detailed views. So we can see granular perspective. It offers multiple views such as view by, perspective by, location, time, or item. So we got various things, and we can now go on to the various OLAP operations, online analytical processing operations. Some of the operations are slice, dice, pivot, roll up, drill down, drill across, drill through. And we can see them one by one. So here we take an example scenario so that we can see this operation by using the particular data warehouse data cube as an example. So here the data cube constructor has three dimensions, such as location, okay, location, time, and item. And the location, uh, there are various attributes such as city, state, and in time is divided into quarters or years, and items is summarized as electronics, furniture, and so on. So I need to understand the various things. So if, for example, location may be some of the cities like Vancouver, Toronto, so cities of Canada state. Okay, and the time is quarter one, quarter two. Okay, and the items maybe electronics, furniture. Okay, so we can see a slice operation, simple slice operation can slice down a particular 2D slice from the 3D cube. So particular slice of two-dimensional matrix could be segregated or splitted down from the three-dimensional data cube. Example, we are analyzing things for a specific quarter. So for a specific quarter, we need a analysis trend. So we need to slice down the particular quarter alone for a quarter Q1. So this for quarter Q1, the particular cube we have to slice on. So this is the quarter Q1, right? So on the time dimension, we are taking the only quarter one, and in other location and item dimension, all the elements will be there. Okay. So that is the display component here, the output for the slice operation. So here you can able to see the various components for the quarter one. So the various items present are home entertainment, computer, phone, security. The various data are various location or Vancouver, Toronto, New York, Chicago. Okay, and the data available for the various details are specified here within the slice. And you have to understand what is the slice operation. Okay, so next is the dice operation. Dice is it selects a subcube and certain specific range or values are specified. Okay, and it selects a subcube from the data cube. Okay, from the main cube. Okay, it is a type of three-dimensional retrieval from a multi-dimensional cubes. Okay, so here a small subset of subcubes are taken from the particular larger cube. So here, for an example, we can take analyze sales for Q1 and Q2 in Vancouver and Toronto. So we need to take Q1 and Q2 data in Vancouver and Toronto. So only we need for Toronto and Vancouver. Okay, Toronto and Vancouver for Q1, quarter 1 and quarter 2. So see here, we are just taking, okay, taking a particular dice of a bigger data cube. So this is the particular dice containing the quarter Q1, Q2 and Vancouver and Toronto. So this is the output. So here Q1, Q2 and Vancouver and Toronto. So the equation for dice is query for trying the dice is dice for location equal to Toronto or Vancouver and time equal to Q1 or Q2 and item equal to home entertainment or computer. So we are getting a treated dice. Okay. So next is the pivot operation. Pivot operation includes a rotation operation. Okay. So rotation, it rotates the data cube to view data from different perspective. So for a specific slice of data from the data cube, we can use the pivot operation. So these are the various components of pivot so that we can able to analyze the sales data item over the various items and location instead of location by items. Okay. So here how we have to do the pivot operation is just switch the x-axis into y-axis and y-axis dimension into x-axis. So here we are just translating the location dimension into x-axis and items dimension into y-axis. So the same 2D tables is translated into switched in into other so that you can able to enhance the flexibility in while data visualization. So next is the roll-up operation. So roll-up operations aggregates data into to a higher level of abstraction. So it aggregates the existing detail level into higher level by combining the detail level and aggregating into higher order. Okay. So for example, city data could be converted into countries. Okay. So for example, Vancouver and British Columbia are cities of Canada state. Okay. So instead of we need the location, we specify the Canada instead of taking the specifying the cities. If we specify the this country name Canada, it will just pick the only the existing cities of Canada state. Okay. So here Vancouver and Toronto are the cities of Canada. So for that, this level of roll up operation has been performed. So this will combine these two into a single entity. Here, the cities data are aggregated into state data, such as Vancouver and British Columbia. Those are the cities belonging to Canada. Is being aggregated into Canada. So here, the Vancouver and Toronto for each and every quarter is being summarized and drawn together as a simple Canada file. So here, the detail E95 and 605 has been summarized into 1000. Similarly, for Chicago and New York are the states of or the cities of United States of America. So here, the data is being 440 and 1560 is being and then joined together into USA. Next, we can see about drill down operation. Drill down operation provides more detailed data moving to the lower levels in the hierarchy. So for a particular time dimension, we are splitting the individual quarters into various months. Okay. So here for quarter Q1 are being detailed in the January, February, and March. So for a particular quarter detail 400 is being split into January 1150, February 100, and March 150. So it is how the granular analysis looks. So also, each quarter has been splitted into its own month. Okay, its own months. Okay, so quarter space being split into April, May, June. The way remaining months also is that. Are seeing this? You can able to manipulate a particular location and time, product, and customer. And this is another chart. Okay, another dimension. And here there are 4 dimensions. One is product dimension, having the items. subcategory and category. Okay, these are the various attributes in the product dimension. The location dimension, country, brands, continent. Time dimension, year, quarter, month. And in customer dimension, buyer and buyer group. Well, this is a particular details of the particular data cube. So yeah, from this data cube, is more generalized by 2006. Time is more generalized and specified in year. So is we specified in particular year for a particular customers, all the customers, and particular product category. Product category means is food or non-food. That is the product categories. Okay, for a particular product category and for particular countries such as oil and Japan. So for here, year view. Okay, so when we use the from this data cube to when we use the drill down operation, it will split the each individual year into quarter. So it individual so with the detailed shot the for 2008 is split into four quarters Q1, Q3, Q3, Q4. All the particular this entire row is being split into these various set of quarters. So when we sum all this, we get this because this 5600 is being split across for all the quarters. Okay. So and in addition, so the outcome is that this row. Okay, to those 5600 is 900 and also 5%. So yeah, when we again use drill down operation for quarter one, it will be coming to month the time dimension by month. Okay, so the quarter one is the separated as a month, January, February, March. So this month for a particular month, the total is 1500. So this is 1500, 500, 2 billion and $1. So this is drill down operation and drill up operation or roll up operation is opposite to this. From the specific view or specific detail view, we are moving higher up to the hierarchy. From the lower level, we are drilling up or rolling up to the higher levels. So next is the drill across operation. So drill across operation links to related data from multiple fact tables. So multiple data cubes are used there. So we are looking onto the same details into multiple in order for comparing sales statistics along the purchase data. We can use this kind of drill across operations. So the cross analysis between various data feeds can be established. But yeah, the same data for dimension, time, product, and uh, location for in sales cube and same dimensions of time, location, and items product for the purchase cube is being displayed. Okay, so the same things are being there for the year 2006. This is the sales table data, how much the sales have been done in a particular shop, in a particular food, in a particular country. So how many sales have been done? Then the purchase, how much purchase have been made by a customer for a particular food or a particular year and the particular country. So in order to compare this data, drill across operations to be used. So next is the drill through operation. So drill through operation would access detailed transaction data. So when a data or a particular cell, for example, in a toilet or a non-food at the year 2008, the 2900 has been specified for sales. So when we detail this or for each and every individual day in the year 2008 on the various items sold, okay, or how much dollars have been credited by the sold items like that. It is given a particular item, how much units sold, how much dollars produced. For 2015, so there's 900 and 300. When summarizing all this, we get 2900. Summing it all, we get so this is Gilco operation. These are the various operations of oil operations.